Hello, fifth graders. Welcome to lesson 713 of math. We are nearing the end of our unit, and today we are continuing on with looking at tables, rules, and graphs, as you've been doing in the last few sessions. At this point, hopefully you have watched the National Geographic video of Old Faithful, which is a geyser found in Yellowstone National Park. Pretty interesting. I hope one day that I could see something like that. I've never been to Yellowstone, but it's on my bucket list for sure. So today we are going to be trying to predict the eruptions of this geyser, Old Faithful in Yellowstone. So let's go ahead and read the directions. It says, Old Faithful, one of 200 geysers found in Yellowstone National Park, is one of nature's most impressive sights. Old Faithful is not the largest or tallest geyser in Yellowstone, but it is the most dependable. It erupts at predictable intervals. If you time the length of one eruption, you can predict how long you will have to wait until the next eruption. The formula that describes Old Faithful's eruption pattern is wait time equals 10 times the length of the last eruption in minutes plus 30 minutes. Okay, so from this page, I can already tell that we are going to be trying to predict what the next eruption is going to be for this geyser. Okay, so it says use the formula to complete this table. Write each pair of values from the table as an ordered pair. The first one has been done for you as an example, and then we're going to plot each point on the grid and use a straight edge to connect the points. So we're already given a rule. Essentially, our formula is our rule. Our inputs are going to be the length of the previous eruption in minutes, and the wait time is going to be in the Y column, okay? So the first one has been done for us. So using our rule, let's double check our work. It says the length of the previous eruption in minutes was 1 minute. Now it says you're going to take the wait time and multiply it 10 times the length of the last eruption in minutes. Okay, so length of the previous eruption in minutes times 10 gives us 10. Now we're going to add 30 minutes. 10 plus 30 equals 40. Okay, and we can see that that is the correct answer. Now let's try the second one. Length of the previous eruption in minutes. Well, using our in rule, it tells us that we have to take the length of the previous eruption, 2, multiply it by 10, which would give us 20. And we're going to add 30 minutes onto that, okay? 20 plus 30 equals 50. So I know that the next wait time is going to be 50 minutes. That wait time tells us how long is going to be between those eruptions, okay? So now I'm going to write this as an ordered pair. Remember, X comes first, Y goes second. So my first order pair is 140. My second is going to be 250. Okay, let's try one more example. I'm going to write this example in terms of an ordered, or actually I'm going to use order of operations to write this. So 3, I start out with 3 minutes from the previous eruption. Now it says times 10, okay, and now I have to add 30 minutes. So this is another way that you can write it. 3 times 10, we know we do parentheses first, is equal to 30. I'm left with addition. 30 plus 30 is equal to 60 minutes. So I know that I have 60 minutes of wait time after this eruption. Okay, so my third ordered pair is going to be 360. Okay, now, after you find all of your values, I'm going to let you go ahead and do that on your own. One thing to note is that at the very end, you are given your Y value, or your wait time, and you have to work backwards. So as a hint, as you can see here, our answer is given to us. Let me make sure you can see that. Yep, our answer is given to us. We're going to work backwards. So we're told that 35 is our answer. And we know that this is our formula. 10 times the length of the last eruption, I'm going to use an L, plus 30 minutes, okay? How can we work backwards from here? Well, I know that I added 30 to get this answer, so I'm going to subtract 30 from both sides, and I end up with 5 equals 10 times the length. Okay, and I think you can take it from there. That's just a hint. All right, so now I'm going to go look at my chart and plot my points. Notice on this graph, we have the length of the eruption in minutes as our x value. Length of previous eruption in minutes matches our table, and wait time in minutes, which matches our y value in the table as well. So what I'll do is I'll go start 1 on the x-axis and find 40, plot my point, 2, 50, plot my point, 3, 60, and I'm noticing a bit of a pattern. See if you can continue that pattern on. Use a straight edge to connect those points and figure out what that pattern might be. Once you have filled out those tables and charts, you are going to look down at the bottom. It says it is 8:30 a.m. and Old Faithful has just finished a 4-minute eruption. At about what time will the next eruption occur? Well, we have to figure out what the wait time would be after a 4-minute eruption. Fortunately for you, after you've done your chart, you will have the answer to that. You will know how much time will be in between those eruptions. So from 8:30 a.m., you can figure out what time the next eruption would be, and then you're going to explain how you found your answer. After you complete that page, take a look at the math boxes. I know Mrs. Trumbull's class is optional. Mr. Benson requires you to do the math boxes, so make sure you get those math boxes done. Afterwards, be sure to post pictures of your work, and also don't forget to upload a picture of your HomeLink 713 as well. Let us know if you have any questions.